electricity will go down a wire and do something like light up or run a motor. And we also know that magnets can attract things, can pull on things, and they can pull on other magnets, and they can also push on other magnets. Magnets can push on each other. So that's all interesting, and people have known that stuff for hundreds of years. But where's the connection? Well, in 1820, a guy named Oersted was playing with magnets and electricity. He was giving a demonstration actually, and he happened to notice that a little tiny magnet, which was a compass, moved whenever he connected up a circuit. There was a circuit right next to it, and he connected. He was kind of a messy guy. There was mess all over the place, and right next to the circuit was the magnet, and when he connected the circuit, the magnet moved. And that was the beginning of electromagnetism, the connection between electricity and magnetism. So we can do that same thing right now. If you get a little skinny wire and a little magnet like this, and the wire is all kind of floppy, and then if you put it next to the magnet, then you connect it, the wire jumps. It's difficult for you to see perhaps because it might look like I'm moving it. I'm just connecting the circuit. The electricity goes running through there, and then it moves next to the magnet. I'm going to turn the magnet around so the other pole is there, and then when I connect it, it does something else. Now it's moving up, it's jumping when I do that. I'll turn it a little bit more towards you so you can see it. So there it is. That's called a motor effect, and that's what makes motors turn. You've got electrical current pushing on a magnet, pushing and pulling on a magnet. And that's just with one wire. All you need is one wire, because when there's a current going through the wire, there's a magnetic field around the wire. So if you take that wire and wind it around and make an electromagnet, like maybe you've done, then you've got a lot stronger magnetic field, and you can push on the magnet or pull on the magnet, and you can actually make the magnet move. And turn it this way and push on it, and you can't see it, but it's moving. That's moving a little bit, pushing on it from this side. And you can pull things into the magnet, or into the electromagnet, and if you stick a nail in there, then it makes a stronger electromagnet. And if you take apart a motor, these little motors, if you take it apart, you find inside these two little things over here called brushes, and then the rotor. The rotor is mounted on the shaft. That's the shaft. This is the rotor. The rotor's got three little electromagnets. They're all wound around a core. Each one's got a little core. And then they're all connected to this thing here, which is called the armature. And it's got different places where the brushes touch the armature. And when the brushes touch the armature, they make a connection to those three electromagnets. And the connection runs out here to the little ears on the back of the motor. That's how you connect it. When you connect up a motor, you're connecting up one or two or all three of those little electromagnets so that they're ready to push and pull. Well, what do they push and pull on? They push and pull on the little magnets, permanent magnets, that are inside the motor. And so there they are. There's two magnets and three electromagnets. So they're never perfectly lined up. There's always one of them that's kind of outside. And so it wants to turn it, wants to make it turn over to the next section. But when it turns, then the little brush moves over and connects to the next part of the armature and connects up a different set of the electromagnets. And they can be connected in one direction or the other direction, so they can be pushing or pulling. So as it turns, it's also disconnecting and reconnecting, and it keeps on changing the pulling and pushing so that the motor keeps on going around. That's how a motor works. Here we have a little, like a model of a motor. We call it a proto-motor. And with the little electromagnet, you can push on the little magnets mounted on this proto-motor. And so if it's just sitting there and then this little electromagnet comes by, I can push on it like this, boom, and it makes it move. And I can move it like this. I can moving my magnet to make the proto-motor move, but I can also just, if I'm clever, I can just keep it in the same place and I can turn it on right at the right spot. Oh, I gotta get it going a little bit faster. And then it's got a little bit of friction. My little bearing is not good enough on the inside, I think. I'll put it like this, maybe it's better this way. So as I push on the magnets, the thing spins, and that's what's happening. It's exactly what's happening inside the motor to make the thing go around. Only it's not a person connecting it, disconnecting, it's that armature and the brushes. And that was discovered the very next year. As soon as Ørsted saw the magnet move, everybody said, wow, that's great. We can get the electricity to do work for us. All we need to do is make it keep on going. Because it's not that interesting just to have it move one way. You need it keep on moving. And so everybody in the world was working on it, and this guy named Faraday figured it out a year later, 1821, and he had the first motor. And it was turning around and around. And in 10 years, there were all kinds of things powered by motors. And today, there's thousands, millions of things powered by motors. So now you know the story about motors.